The objective of this activity is to develop the concept of direct proportion. Let's study the concept first. Suppose you have two quantities x and y, and you are trying to increase the first quantity x. As a result of increase in the first quantity, if the second quantity y automatically increases, or due to decrease in the first quantity, the second quantity y automatically decreases, then x and y are said to vary directly. That means they are in direct proportion. For example, if you take the example of speed and distance, if you increase the speed, obviously the distance covered will increase, and if you decrease the speed, the distance covered will automatically decrease, and therefore speed and distance vary directly. This is the concept of direct proportion. The material required to perform this activity of direct proportion are graph papers or squared ruled sheets and a pair of scissors for cutting work. Let's perform this activity now.
In this activity on direct proportion, we have drawn a table here in which we have drawn three columns, one showing the squares, the other showing the edge, and the third one showing the area of that particular square. We have also taken out different cutouts. They are all in the shape of squares. You can see they are all different shapes here. So 5 different shapes have been taken. So in the squares column, I'll be writing square number 1, square number 2, square number 3, square number 4, and square number 5. Let's take the smallest square first. So the smallest square here is this one, and for this one you can see the edge, that means the side is 1 unit. Unlike here, where the edge is of 2 units, this is only 1 unit. So if I say that the edge is 1 unit, then the area of this particular square will be 1 times 1, that is 1 square unit. Similarly, if I use the second square here, in which you have how many? 4 small squares, you can see the side or the edge of this square is 2 units. So I'll write 2 here. And what is the area? How many small squares can you see? 4, right? So 4 square units will be the area of this particular square. Let's have the third square now, where we have taken the edge as 3 units. So let's write 3 here. So in 3 units, how many small squares are there? 3, 3 and 3, 9 small squares, and therefore the area of this particular shape is 9 square units. Likewise, if you take the side as 4, see we are increasing the side one by one, so 1, 2, 3, 4 units, and therefore you have 4, 4, 4, 4, that is 16 square units is the area of this particular square. And finally we have taken another one, the largest one here, which has the edge as 1, 2, 3, 4, 5 units. So we will write 5 here, and therefore 5, 5, 5, 5, 5, 25 square units is the area. Now, how does it help us in finding whether the edge or the side and the area are in direct proportion or inverse proportion? As you can see, edge 1 gives area 1, edge 2 gives area 4. So if the side increases, then the area also increases. And likewise, if 2 becomes 3, that means it increases. 4 becomes 9, so it also increases. And therefore we say that the side of the square and the area of the square are in direct variation or direct proportion. The same can be done through more squares of different sides, and you will find that whenever the side increases, the area also increases. And that completes our activity on direct variation.